Hello everyone, welcome to Grade Up. My name is Ayush Goyal and we are studying theory of computation in these subjects, right? In our previous video, we studied about FA, finite automata construction, right? As I said, in finite automata, you will be given a language and you have to draw the DFA for it, right? So in our previous video, we discussed near about 15 to 20 examples in which I gave you a language and you will draw a finite automata for that language, okay? So now, we know what is the basics of finite automata, how to draw the finite automata. As we discussed, first realize the minimal string, draw the DFA for that minimal string and then adjust the remaining arrows or transitions, okay. So that were the basic DFAs. Now we are moving to the product automata. What is product automata? In product automata, I'll apply two conditions. Like the number of A's must be even and the number of A's must be odd. Right? Something like this will use. Okay. So let us start. Let us start with product automata. See, first of all, the first example I'll take. Okay. There is a technique to draw these product automata. Their technique will apply in all the things. Okay. So see here. Contain at least 2 A's and 2 B's. Up till this point, we have done at least 2 A's. And the next example, we decided at least or at most. Now, two conditions are applied simultaneously. That is meant by product automata. Okay, so see here. Contain at least 2 A's and at least 2 B's. It should contain at least 2 A's and at least 2 B's. So, how to draw it? See, first of all, try to do this thing. Basically, guys, this will be realized using grid machines. What are grid machines? See here. First, do for at least 2 A's. See, 1A, 2A. This is for 2 A's, at least 2 A's, right? Now, more A's can come. But at this point, we should also realize B. So do this thing. For A, you use horizontal states. For A, use horizontal states. For B, use vertical states. Okay, see here. You draw the FA for A horizontally. Draw the FA for B vertically. See, at least 2 B's. So, B. Here, 2 B's are over. Okay. Now you have to adjust the remaining things. See here. See, okay. So now you draw the grid machine. What is grid machine? In that you realized the A using horizontal states and you realized B using vertical states. Why I have done like this? See, as I said, it will be a grid machine. Now, you try to do these things, at least 2 A's and at least 2 B's. First, I draw this horizontal line, at least 2 A's. Then I draw this vertical line, at least 2 B's. Then why this machine? See here. A, B. At every step, you will get at least 2 A's and at least 2 B's. The ending state will be here. After this point, anything can come. Because up till this point, 2 A's and 2 B's are already present. Okay. After this point, anything can come. Now, see, to reach this state, you can follow any path from the initial state, but that will contain at least 2 A's and at least 2 B's. See, B, A, B. You can check any path. At least 2 A's and at least 2 B's will be there. Cleared? Any problem in this thing? Right? So this is a grid machine. It looks like a grid. Grid is something like this. So it looks like a grid. That's why I said it is a grid machine. Got it? Any doubt in this? So why it is called product automata? See, how many states are required for at least 2 A's? If you draw the DFA separately for at least 2 A's, it will look like this. You know, I have already explained in my previous video. It looked like this. So it requires 3 states. It requires 3 states. Similarly, if you draw for at least 2 Bs, it will also require 3 states. Now, for product automata, it will require 3 into 3, that is 9 states. See here, 9 states are there. Got it? So that's why I call it as product automata. You will take the product of the language. Clear? Any problem in this grid machine? It is a basic thing you require to draw all other product automatas. Clear? Good. Now see, contain exactly 2 zeros and exactly 2 ones. Now I am moving to alphabet 0 and 1. Okay? Same thing you have to do. Exactly 2 zeros and exactly 2 ones. See here. First, draw the zeros horizontally and draw the ones vertically. Okay? Now adjust. Adjust so that no problem should occur. See? Adjust. Okay? So now you have drawn up till here. This is your final state. Up till this final state, if you have to reach here, exactly 2 zeros and exactly 2 ones. Can more things come here? Can more things happen? No. So you have to take a trap state if more things come. That is a trap. Now everything will go into trap, that is extra. Everything extra will go into the trap. Cleared? Any problem? Here also it will go into the trap. See, this is a finite automata. This is for point number 1. Okay? This is the finite automata. Right? See here, up till this final state, you will get exactly 2 zeros and exactly 2 ones. But after that, nothing can come. That is why trap. Clear? Second thing, contain at most. If you take at most, these all will become final. See, all are final states. All are final. Okay? If you take at most, all will become final state. But after these things, everything will go into trap. Cleared? Everything will go into trap. Right? So, in your exam, you won't be asked to draw the DFA. In your exam, you won't be asked. It will be asking minimum states in your DFA. It will give this question. Consider a language which contains at most 2 zeros and at most 2 ones. What will be the number of states in your DFA? So, how to do it? See, if first method you draw the DFA, or for calculating the states, at most 2 zeros will contain 3 states and 1 trap. You know how to draw it. At most 2 ones will contain 3 states and 1 trap. So, don't consider the trap, consider the states. 3 into 3 will be 9 and combine all the traps in 1 trap. See, only 1 trap I have taken. So, the total states will be 10. You can do this way also. For at least there will be no trap. For exactly and at most there are traps. So, combine all the traps into 1 and the remaining 9. Got it? Either you can draw the DFA or you can do this way. Cleared? Any problem? Good. Now, even A's and even B's. 4 examples I have taken. 4 possible cases. Even number of A's, even number of B's. Even number of A's, odd number of B's. Odd number of A's, even number of B's. And odd A and odd B. 4 possible cases I have taken. Here also I will follow the concept of grid machine. A on horizontal, B on vertical. Follow this concept only. Follow this concept. Okay. So see here how to do it. See, this is the initial state, horizontal A. Okay. Vertical B. Right. Now adjust. So grid machine, maintain grid machine. A, this is also A. And B vertically. I think all the arrows are completed. All the arrows are completed. Now you have to decide what is the final state. Now you have to decide. See here. See. Even A and even B. Even A. First of all, realize what is even A. See. Number of A's must be even. So A, 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 A. Here it will contain number of A's must be even. So here is the state of even A. This is the state of even A. And this is also the state of even A. Right? See here. Number of A's are 0 also. Then 2, 4, 6. So these both are the states. Suppose I number the states 1, 2, 3 and 4. So even A. For even A, the states are possible 1 and 3. Now check for even B. Check yourself now. Even B. Even B. See here. 0B, 1, 2. 2 B's. 4 B's. So 1 is also the state for even B. And 2. 2 is also a state for even B. See 1, 2, 3, 4. So 1 and 2. Now you want to decide even A and even B. Among these, all what is a common thing? 1. So 1 will be a final state. Right? In this way, you can decide even A and odd B. What is the state for odd B? See, third state. Third and fourth will be the state for odd B. So among 1, 3 and 3, 4, which is the final state will be? What is the common? 3. So here 3 will be a final state. Here 1 is a final state. In all these 4 cases, only final state will change. Only finite state. Nothing will change else. The diagram remains the same. Only final state will change. Can you tell me for odd A and even B? Odd A. What is the state for odd A? See, 2. 2 is a state for odd A and 4 is also a state for odd A. So even A and odd A and even B. Odd A and even B. These two. Odd A and even B. So what is the common? 2. So here 2 will be the final state and here 4 will be the final state. Okay. So just change the final states to get these languages. But number of states in all these are same. That is 4. So you draw a common grid machine. The change will be the only final state. Cleared? Any doubt in this? Good. Now see one more thing. Number of A's mod 3 is 1. Okay. What is meant by this? Number of A's mod 3 means mod 3. Either the number of A's are 1, 4, what else? 7, what else? 10 and so on. So the number of A's must be like this: 1, 4, 7 and 10. And the number of B's are mod 2. Mod 2 means mod 2 is 0. Mod 2 0 means 0, 2, 4, 6. Means the number of B's are nothing but even. So this must be the case. This must be the case. In your exam, it will be given and you will have to find the minimal number of states in your DFA. So one thing, you draw the DFA. One option, you draw the DFA. Another option, you can realize using the product automata concept. See, mod 3 machine, how many states it will require? As we have discussed in our previous video, length 3 basically, or mod 3, mod 2, it will require exactly 3 states. Mod 3 requires 3 states. Okay. Mod 2 means even. Mod 3 multiples of 3 will require 3 states. Mod 2 will require, mod 2, how many states will require? 2 states. You have discussed even number of states. So take the product. 3 into 2, it will be 6. Now consider trap will be there or not. In mod machines, trap are not there. So 6 will be the answer. No trap. So either you can do this way or you can draw the automata. See how you draw the automata. See, very simple you do. A horizontal. So draw the automata for horizontal. A and A. This is the automata for mod 3 machine. Mod 3 must be 1. So it is 0 and 1. Here it is your final state. Now draw the B for vertical. So see here, what is vertical? Take another B and B. Maintain this grid machine. Okay, maintain this grid machine. So this is your final machine. Now you can verify. Number of A's must be mod 3 1. So see here, A 1 is accepted. A again 4 accepted, and so on. If you take B's, so B A B. Number of A's 1 accepted. Number of B's 2 accepted. So you can verify all the things from this language. Okay. In product automata, grid machines are required. In grid machine, you have to use horizontal and vertical. Nothing else. Cleared? Any problem in this thing? Good. Right. Now come on to a GATE previous year question on product automata or an automata. I am discussing some good questions, right? See here. The minimum possible number of states that accepts the regular language, this one. You have to draw the, as I said, only number of states will be asked, okay? W1A, W2. W1 length is 2. This means length. The length of W1 is 2 and the length of W2 is greater than or equal to 3. And there must be a in between. So start. Now how to draw? See. First of all, W1. W1 is where length is 2. So draw. See. Length is 2. Length 1. Length 2. It is up to length 2. And length, anything can come A and B. No problem at all. Now W1 is over. Now A should come. So A. This A also over. Now W2. What is W2? Whose length is greater than or equal to 3. So length 1, length 2, length 3 and now greater than or equal to 3. So it is accepted. Length means anything. Length means anything and now length is greater than, so anything can come now. Okay. So this is the state. This is the finite automata. Now look, A and B, but here only A. If a B comes after W1, only A can come. If a B comes, you have to go to trap. I think all the transitions are over. All the transitions are over. Okay. So now count how many number of states are there. How many number of states? See, 1, 2, 3, 4, 5, 6, 7 and 8. Got it? Number of states are 8. It is by mistake written as 7, or if you want to, you can verify also. W1 length is 2. So length 1, length 2. Okay, over. Now A, yes, completed. Now length greater than or equals to 3. So length 1, length 2, length 3 and then a final state and then also a trap state. Okay, so the answer is not 7, answer is 8. Cleared? Right? Any doubt in this? Answer is not 7, answer is 8. It must haven't count the trap state. But as said, deterministic finite automata. In deterministic, you have to count the trap state also. Cleared? Any problem? Good. Next, GATE 2017 again. See, consider the language L over the expression this. Now you have given an expression. A regular expression is given. And it is asking again the smallest number of states. Right? So draw. How to draw it? See, I will teach you regular expression later, but it is easy to realize. See, it is saying anything can come. Anything can come. A plus B star means anything can come, but it should end with, if I open this bracket, it is BA plus BB. Okay, it is saying it should end with BA or BB. Right? It should end with BA or BB. Now let us try. First, the minimum string is BA. So draw the DFA. B, A will be accepted. Next BB. So B will be accepted. Now adjust the remaining arrows. Just adjust. See, I'll start from here. State number 1. B is here. Where is A? Any number of A's, because anything can come. So A is a self loop. Now here, A and B, both arrows are there. Here A. So I cannot make a self loop of A because it must not end with multiple A's. So if A comes, you have to go to this state, previous. But if a B comes, you can go here. Why? Because BA, multiple BA's can come. Okay, see here now. B, you can make a self loop of B because it's ending with B, any number of B's can come. But if a A comes, you can go here. Why to go back? Just realize it. See here, BA, then BA, it will be accepted. So how many states? 4 states are there. Cleared? Any problem in this? Right? Just you have to do some practice. Without doing practice, you cannot do this thing. Okay? I hope you are clear with this thing. Good. So guys, that's all about our product automata. Now we have discussed approximately, suppose 25 examples. Approximately we have discussed 25 examples on finite automata. Guys, there is no depth of finite automata. No depth. You can find 2000 examples even on finite automata. Seriously, 2000. But I cannot discuss all. right? If I'll able to discuss, I will. But there is no scope to discuss all the things here. So I have tried my best to discuss every point, every basic. I have told you the technique, how to do this. Now, it's your duty now to practice as much as possible. Pick up the book, Peter Lin's, or any book you pick up. You will find many languages there. You will find many languages. Pick up any language and try to draw the DFA for that. Okay? If you will do practice, then you will be only able to do the questions that are asked in your GATE exam or PSU exams. In GATE exam, very easy question will not be asked. Something different, something good, challenging will be asked. So for that question, you have to practice so much. Okay, so now pick up the book Predator Lanes or any other book, or pick up the previous year and practice as much as possible. At least you should practice 200 questions for DFA. At least 25 questions are not enough. 200 questions are minimum required to be comfortable with this thing. Okay, so practice now yourself. If you have any doubt, post on the app. We'll surely answer you. Okay, 100%. We'll see your problem and we'll give an optimal solution to that problem. Okay, so now in next video, we'll see some algorithms on FA, how to reverse FA, how to complement FA. Okay, we'll see all that things in our next video. So stay updated. Thank you so much.